Okay, so I'm going to attempt here to do a as quickly as I can, video of Module 14, all of Module 14. So it's really just a lot of rules, and again, I'm going to try to go through this as quickly as possible. So let's start with some basics. So one of the most basic rules, these have to deal with powers or exponents. Anything to the 0 power is 1. Okay, anything to the 0 power is 1. It's because if you want to understand this, we'll get into it a little bit more as we talk about positive and negative exponents. That also includes numbers. So if I have 5 to the 0 power, that's a bad 5, but anyway, if I have 5 to the 0 power, that is also 1. Okay, so anything to the 0 power is 1. All right. Let's talk about negative exponents. What if I have x to the negative 1? Well, if I have a negative exponent, you want to make it positive. And the way you make it positive is by doing the reciprocal. Now, we've talked about this before, but you've probably heard in some cases reciprocal. So this now becomes 1 over, now that becomes x to the positive 1. Okay, so if we talk about a number, let's say 5 to the negative 1 power, then that becomes 1 over 5 to the first. Okay, so that's what it would look like written to a positive power. Now, if you think about that in terms of a numeric value, what's 1 divided by 5? That is 0.2. Okay, so now let's go back to the idea of to the 0 power. So if I do like 5 to the first, that's 5. So what we have is we have this kind of number line here. 5 to the negative 1, 5 to the 0, and then 5 to the first. Okay, so this is 0.2, this is 1, and this is 5. Now, what are we talking about? We're talking about a base of 5. So that means every time we're multiplying by 5. So what's 5 times 0.2? If you do 0.2 times 5, you get 1. If you do 1 times 5, you get 5. So that's kind of how this to the 0 power becomes 1. I don't know if that clarifies it much, but so just some basic things. Anything to the 0 power is 1. Okay. If it's to a negative power, you flip it, you do the reciprocal, and make it a positive exponent. Okay. The other thing we're going to talk about is when you're dealing with numbers, try to do numbers on the calculator. It just makes things a lot easier. All right, let's go to the next page. Okay, so 14.1 really starts with fractional exponents, okay, or what we call radicals. So, for example, let's talk about square root, okay, square root of 4. Now, really what square root is, it's kind of like if we do x, remember that is really x to the first power, and it's multiplied by 1. Okay, so when we do square root, that is really a 2 there. We just don't write it, but it's assumed to be there. Now, all that really means is it's really 4 to the 1/2 power. Okay, 4 to the 1/2 power. So that's what a root means. So as we go through, if you see something like cube root of x, that really means x to the 1/3 power. Okay, or if you see something like 5/5 root of x to the second, then really what that is x to the 2/5 power. Okay, so the 2 goes on top, the 5 goes on bottom. Okay. Now, what we're going to do next is we're going to address some basic rules of exponents, and then we're going to talk about how do you simplify these things. How do you simplify them? Okay, so first of all, let's talk about when you multiply. So what does x to the second mean? X to the second really means x times x. You have two x's. So when you multiply things with exponents and like bases, okay, what do we mean by bases? That's the base. X is the base. So if I have x to the second times x to the fourth, okay, if I expand that, expansion notation means x times, okay, so that's that big multiplication symbol, sorry, x times x times x times x. I have 4 of them. Well, how many do I have total? 1, 2, 3, 4, 5, 6. So that is x to the 6th, okay? So there's a shortcut rule to this. Now, you can always do expansion notation, but the shortcut is this. When you multiply like bases, then you add exponents. So really this becomes x to the 2 plus 4. I'm taking the exponents here and I'm adding them together, which gives me x to the 6th, the same thing I got up here. Okay, so what about if you have multiple variables with coefficients, numbers? Okay, so let's say 5x to the second, y to the third, times 7x y to the fourth. Okay. Again, like I said earlier in the video, do the numbers on the calculator. Okay, just do 5 times 7 on the calculator and get 35. Always deal with your numbers first. Then deal with your variables. Okay, these are like bases, x and x. Remember there's a 1 here. So when it's multiply, I add exponents. So that would be x to the third. Then I do the same thing with my y's. 3 and 4 would give me y to the 7th. Okay, so now let's talk about division. Okay, so if we multiply, we add exponents, then division you would think is probably what? Subtraction, and that's correct. Okay, so let's talk about this. So let's say x to the 6th over x to the 4th. Now if I do expansion notation again, it's x times x times x times x times x times x. I've got 6 of them. On the bottom I have x times x times x times x, 4. So what happens? 1, 2, 3, 4, and that leaves x to the second on bottom. Now what's it, or on top? Now what's it leave on the bottom? Technically there is a 1 there, just because there's a 1 right here. Okay, just like there was a 1 right there. So again, if you simplify that, that's just x to the second power. Okay, what happens if you invert it? So if I did x to the 4th over x to the 6th, okay, then I have x times x times x times x over x, 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 x. 1, 2, 3, 4. Those all cancel. So I'm left with x to the second on bottom. But again, remember, there was a 1 here, just like there was a 1 there. Okay, so this one on the top can be simplified to just that. This has to be left like that. You got to leave that 1 on top. Now, again, the shortcut rule is this. When you divide, you subtract exponents, and you always subtract the smaller from the larger. So I move the smaller one up. That becomes 6 minus 4. What's it leave on the bottom? A 1. And that becomes x to the second. If I did the other problem, x4 over x to the 6th, I move the smaller to the larger. That leaves a 1 on top, and on the bottom I subtract my exponents, and I get 1 over x to the second. Okay, so that's multiplication and division. What about if you raise a power to a power? Okay, for example, let's say I have x to the second raised to the third power. Okay, so really what that is x to the second times x to the second times x to the second. Because if you raise it to the third power, it means you're multiplying it times itself 3 times. Now we're back to the rule we just learned. When you multiply, what do you do with exponents? You add. So that gives me x to the sixth. So what's the shortcut here? The shortcut is when you have a power to a power, you multiply. Okay, so I have x to the 2 times 3, which gives me x to the sixth, the same thing I got right there. Now, what happens if you have a coefficient in there? Okay, so let's do 5 again. Let's say we have 5 x to the second raised to the third. Well, again, just do the number on the calculator. So we get 125. Okay, if you do 5 caret raised to the third power, that's what you're doing on the calculator, that's going to give you 125. And then we deal with the variable, which is x to the sixth, which we just learned at the top. Okay, what if you have another variable added in there? So I'm going to move this up. So say for instance I have 5x to the second, y to the fourth, all to the third. Then again, just deal with your number on the calculator. 5 to the third is 125. Then multiply your exponents. 2 times 3 is 6, like we just got earlier. 4 times 3 becomes 12, so you get y to the 12th. Okay, so let's go back to the whole radical thing, or fractional exponent. So what happens if I have the cube root of x to the sixth? So really what that is x to the 6 over 3, because remember that's really the 1/3 power. Okay, so if you want to think about it, it looks like this: x to the sixth to the 1/3 power, and we just learned when you have a power to a power, you multiply, so you get 6 over 3. But what's that reduced to? X to the second. Okay. What if you have a number in there? Okay, so let's say I have the cube root of 125. Okay, there's a couple ways to do this on the calculator. One is you can just type it in as 125 raised to, now if you don't do the alpha y equals button, then it's parentheses 1 divided by 3, okay, and that's going to give you 5. If you do the alpha y equals button, then it's 125 raised to, and then you'll do alpha y equals, and it's 1/3, and it would look like this on your calculator, and then you still get 5. Alright, what about if we get a number that's not exact, okay, a decimal kind of number. Say for instance we get something like this. So 8, and we take the 4th root of 8. Okay, so if I do that on the calculator, I get a decimal number. Well, that's because this one does not work out exactly. Okay, it doesn't work exactly. The way you could think about it is you try to break 8 down to its basic base number, or root number. So really, that is 2. 2 to the third. 2 to the third power gives me 8. Well, 4 won't go into 8. In other words, when you do it, you're going to get 2 to the 3/4 power. Okay, that doesn't really simplify. Okay, let's take it one step further. What if I have variables in there? So let's do this one. Let's do the cube root of 8 x to the 5th y to the 6th. Okay? So always try the number on the calculator first. So, try to do 8 to the 1/3 power. If you do that, you get 2. Okay? So that's good. Now I deal with the variables. So this now becomes x to the 5 divided by 3, and then y 6 divided by 3. Okay, now what's that look like? So I'm going to mark this out so it doesn't confuse you here. So does 3 go into 5 evenly? No, it becomes a mixed number. 1 and 2/5, right? Does 3 go into 6 evenly? Yes, y to the second. Okay? I need to go back, not 2/5. I'm sorry. That should be 2/3. Sorry. Misspoke and miswrote there. 2/3. Alright, so these are exact. So they come out. 2 and y to the second. I have a whole x right here. That can come out. This fractional part has got to go back under the radical. In other words, that 3 was my radical symbol, and I have 2 x's in there that can't be divided evenly by 3. So I had one whole x that came out, but I had that remainder of 2. Okay, so let's think about this. What if I wanted to do the 5th root of x to the 8th? Well, how many times does 5 go into 8? One time. So that one whole x comes out with the remainder of what? 3. So I still have, under the radical, 3 x's left, because those would not come out evenly. I hope that kind of made sense to you. It's a little more complex thing to understand. Okay? One last thing to do. What happens if you have a fractional or a radical that's a negative? So say for instance they wrote it like this: x to the negative 2/3. Then really that is what? 1 over x to the 2/3. Okay? What if they want you to write it as a radical? Then really that is 1 over x to the second, and then I'm dividing by 3, so that means it's the 3rd root. And that's what it would look like. So just all that is, it's the same thing in different ways. These are all different forms of the exact same thing. So let's do one more complex kind of problem. What if we throw in negatives and division and multiplication and all that kind of stuff? So let's say I have x to the negative 2, y to the 3rd, z to the 1/3, all over x to the 1st, y to the 1st, z to the 5/3. Okay, so remember your rules. To take a negative exponent and make it positive, you do the reciprocal, which means it's got to go down here. So there are no more x's on top. Okay, so I have x to the 1st and I have an x to the 2nd on bottom. With the y's, when you divide, what do? You subtract and you move the small to the large. So I have y, and on the top I have 3 minus 1. Now, what about these fractional exponents? You still do the same thing. Since it's division, you subtract and you move the small to the large. So that goes down here. So you have z to the 5/3 minus 1/3. Okay. So on top, you're left with y to the 2nd. On the bottom, remember when you have multiplication, you add exponents. So that's x to the 3rd. And then on that, you have z. What's 5/3 minus 1/3? Would be 4/3. And then if you needed to rewrite that, okay, simplify that. How many times does 3 go into 4? 3 goes into 4 one time. So that means I have one whole z outside with a remainder of what? 1. So I have another z under the cube root. Okay. I know it's a lot. I know I tried to make this video as short as possible. The thing you need to remember, taking these notes is critical. Okay, make sure that you have these in front of you, because we're going to do the homework with these using some sort of online type thing, not necessarily the book homework, but some sort of online homework for you to do these and just review these skills, get some practice. This is just a drill and skill kind of thing, is all it is. And then we'll see the application of these later on.